Hey there, everyone, it's Alejandro, and welcome back for day 246 of me doing Daily LeetCode Challenge that they reach 1 year's worth of recontributions here on GitHub. So today's problem is for March 19th, 2025. Without further ado, let's get straight into it. Okay, today we get LeetCode Medium problem 3191, minimum operations to make binary array elements equal to 1, 1. Okay, you're given a binary array nums. You can do the following operation on the array any number of times, possibly 0. Choose any 3 consecutive elements from the array and flip all of them. Okay, like, binary array. Okay, so zeros and ones. Flipping an element means changing its value from 0 to 1 and 1 to 0. Sure. Return the minimum number of operations required to make all elements in nums equal to 1. If it is impossible, return -1. Oh, it's going to be one of those. We've solved this type of stuff before. Okay. By the way, it's late at night for me. I just dropped my girlfriend off at the airport, and yeah, well, no excuse for this problem, but yeah, in case I have a bit of a groggy voice, I do apologize in advance. Yeah, we've solved these types of problems in the past. Usually things like this is like there's always some nice trick where it's like, you know, it ends up being like you can actually flip anything you want, right? If you have X, Y, and Z, or like, you know, A, B, C, D, and E, it's like, okay, let's say you flip these 3, right? And then it's like you flip these 3, right? And then it's like, okay, then this becomes flipped back. And it's like, okay, you didn't really do much, right? Yeah, I guess you're able to, you know, flip 2 that are like, you know, 4 away from each other or something. That's 1 power gives you. Then you should flip all these. If I flip A with B and the C, yeah, obviously I can get back to a point where I have things unflipped again. Okay, so I have to have either 3 flipped or, yeah, okay. Okay, yeah, let's look at an example. 0, 1, 1, 1, 0, 0, 3. Why? Okay, choose elements at indices 0, 1, and 2. Flip them. That makes them that. Yeah, there's 2 apart like this. Yeah, there's going to be some trick to it, right? Also, why can't you just flip these guys straight off the bat? Oh, make everything equal to 1, not the other way around. Yeah, so this is what I mean. Is it going to be like one of those things where it's like, you know, as long as it's divisible by 3 or something, yeah. Here's like, you know, how many ones were like in between these or something like that, right? Here, okay, it's -1, right? Like, yeah, here it's suspicious that it was like, you know, is it the number of ones? Right? Num zeros. It's, yeah, there's usually some type of trick to these types of problems. It is a minimization problem, so you can always do DP, divide and conquer, or, yeah. I mean, actually, DP would be nice. What are the time constraints for this? It's linear, right? Actually, yeah, something like DP would be quite... no, I have to make sure that the rest of the array is fine. Right, because it's going to be a bit of backtrack sauce, right? Although here it was just forward. Yeah, basically you need to bring these zeros. You need to bring the zeros to groups of 3, right? So that you can flip them all, isn't it? Yeah, so basically you need to bring the 0 over here. And I'm gonna guess that like the number of ones in the way is not random. So like there were 3 ones in the way of this one. It's like, yeah. Num zeros is equal to 0. Cost equals 0, res equals 0. For num and nums. If num is equal to 0, then num zeros plus or equal to 1. Zeros is equal to 3. Num zeros is equal to 0. Cost is equal to 0. Alright, we'll just flip them all. For now, we're just like, let's assume that we can just pass, and like if we get some test case wrong, we'll get that test case wrong and so on. I'm just trying to solve this problem fast tonight. If num is equal to 3, yeah, constant would be equal to that. Yeah, so like this, and then continue, right? Otherwise, assert num is equal to 1. And here, what will you do? We'll do cost plus or equal to 1. Res plus or equal to cost. Yeah, something like that. Turn res if cost equals 0, else -1, something like that. Actually, is something like this enough? Okay, so it's accepted for these two cases, but I'm gonna guess we like fail something in the general case. Yeah. Wow. Okay, 118 is pretty nice. Oh, we want to turn things into ones, right? Cost equals 3. Actually, print f string res equals cost equals. This is kind of weird. Yeah, it might be something like when I added the third num, I see. Should I always reset cost to 1? Something like this? No, these guys are wrong. No. Turn res if num zeros. 0 else -1. Okay. Something like this. Not quite. Yeah. Let me think here. Obviously, you can't pay 0 cost. There were 3 ones in the way. Max of cost, 1 maybe. Okay, let's submit. Yeah, okay. So here, yeah, so the output, so expected is 3. Here it's like, okay, there were 3 in the way. Yeah, that's it. Yeah, this is not a coincidence at all. Okay, I think we actually got it out of luck. Yeah, it's just gonna be like whenever you want to regroup a group of 3 zeros, it's like that's pretty much it. Set this to 0. Gotta get up, try. Shouldn't this be 1? Yeah, it should be a cost of 1 if there's 0 ones in the way. Here I have an overestimate though. Right. Here, what will happen? Cos becomes 1. I'm including this one over here. If num zeros equals 0, cost equals 0. Something like that. Yeah. Okay. Gonna slowly debug our way through this thing. Alright, so something like this, expected 9. So these two had to get through 2. Oh wait. Actually, why the hell is this possible? Oh, no way. I can start turning... Oh no. Yeah, those can cancel each other out. These can cancel each other out. No. 1, 2, 3, 4, 5, 6, 7. Wait. 2, 3, 4, 5, 6, 7 zeros. You can really do it? Okay. Yeah, these types of problems, there's usually some trick to it, right? Where it's like, let's count. How many printf string, count 1, sum of no, equal 1 for num and nums, count 0, let's go to 0 for num and nums. Eight, 3, 1. Interesting. Maybe do I just do a linear scan and whenever I see a 0, it's like I just flip? Is this something as easy as that? Trial 1. Algorithm. Whenever we see a 0, perform a flip operation. If we see a 0 in last 2, okay, we return -1. It might be something as simple as this, right? We will say for I in range of nums, for I, comma, bit and enumerate nums, if I plus, so if we're in the last 2, this is length of nums minus 1, length of nums minus 2. Greater or equal to length of nums minus 2. Right, then we're screwed. Return -1. Alright, otherwise, if bit is equal to 0, then we'll say I plus 1 XOR equal with 1, right? 0 XOR 1 will be 1, 1 XOR 1 will be 0, so we're just flipping it. Nums of I plus 2 greater or equal to 1. res equal to 0. Here we'll do res plus equal to 1. All right, and then continue. Right, if we see a 1, then we're chilling. Return res. Is it something as simple as this? Okay, it might be, huh? That's it. Okay, there we go. Completion streak 246 days. Consistency is key. See ya tomorrow. Okay, yeah, I was just overcomplicating this like crazy. Okay, yeah. I'm so, yeah, we've had this type of problem, I think, in like the weekly LeetCode contest or something like that. No, not this problem, but like something similar. And it ended up being that like it was like some weird condition where like you can only like, you know, flip 3 elements or whatever, something like this. And it's like, it was the equivalent of like, oh yeah, if you do a little bit of magic, then it's like, you can actually flip anything you want. So it's like the answer is just like the number of zeros type of thing. So I wanted to make sure like, you know, this problem is, I wanted to see if this problem was like one of those where it's like, oh, by changing 3 consecutive elements, you can make it to flip just any single element you want in like one operation or whatever. So something crazy like that, where it's like the minimum is obvious. But the answer is just even more obvious. It's just like, you can't have any zeros. So if you see a 0, well, you know, flip it, and which will in effect also flip the next 2. But the point is, you cannot afford to have any zeros. So whenever you see one, there's no choice. You gotta flip. And if you run out of space to flip, then you just return -1 because there's no solution. That's, yeah, I overcomplicated this way more than it needed to be. Yeah, so here we can just do if bit equals 1, continue, and then just like, yeah. Here we'll just put in assert bit is equal to 0 as a comment, and there we go. Yeah, beauty. Yeah, nice. We'll just run this again. And yeah, there we go. That's pretty much it. Okay, a little bit of a slow solution, but yeah, we're right there in the standard deviation, which feels very nice and fantastic. Bada bing, bada boom, there we go. So nevertheless, as always in my videos, I do a quick recap if I will solve the problem. So this one, it's actually, I definitely overcomplicated right at the beginning. This is a lot simpler than what I made it out to be. So essentially, we're given a binary array nums. So this means it's only zeros and ones. You can do any of the following operation any number of times, possibly 0, by choosing any 3 consecutive elements from the array and flipping all of them, right? So 0 to 1 or 1 to 0. And the goal is to essentially make everything a 1. And the way that I solve this is extremely simple, right? You take an array like this, and essentially we're just going to do a linear scan from the left to right. And what I'm going to say is like, okay, wherever our index I is, what I'm always going to say is like, okay, let's say we start at index I is equal to 0. I'm going to look at the current number. I know that I want to make everything equal to 1, right? So I'm going to look at the current number. If it is not a 1, then I'm going to say, hey, it is a 0, I must flip it. First of all, can I flip it, right? Because we're only allowed to do any 3 consecutive elements, and I'm going to do a linear scan from the left to right. So here's like, okay, I must flip this one, the next one, and the next one, right? And so if I were like, you know, if my index I were somewhere like over here, for example, then there's like, you know, 1 number I can flip, 2 numbers I can flip, but I don't have a 3rd number I can flip, right? So you'll see in this for loop, like, you know, if I is greater or equal to the length of nums minus 2, meaning that like, you know, it's over either here or here, then it's like we're screwed because there's not enough space to essentially flip zeros. So the easy case is, you know, if this is a 1, then it's like, okay, it's already a 1, so we're not going to do anything, basically. Oh, this is a 1, we're not going to do anything. This is a 1, we're not going to do anything. This is a 1, we're not going to do anything, etc., etc., etc. Right? So if it's a 1, it's very simple because we want the array to all be 1. So it's like, let's not flip a 1 to be a 0 unnecessarily, right? If it's a 1, let's keep it a 1, right? Otherwise, if it's a 0, essentially I'm going to realize, okay, we need it to be a 1. So what am I going to do? I'm going to flip it here, right? But in order to flip it, I now do 3 consecutive elements. So I'm always going to do the current index, flip it to a 1. I'm not going to look at previous indices because I'm going to assume that all my previous indices are 1s, right? Because I'm going to go through this array and have set everything to 1s. So I'll only consider the current element and the next 2, right? If there are no next 2, then I know that it was impossible for the problem. So for something like this, let's keep track of like, you know, a res variable, which is initially equal to 0, which will be the number of flips that we do, right? And so here we see a 0. we want all the numbers in the arrays to be 1, so we'll do a flip operation, right? Starting with this element, so we'll flip this from 0 to 1, we'll flip this from 1 to 0, and we'll flip this from 1 to 0, right? And res will increment it by 1, so it'll not be 1, right? And now this number is a 1, so we're like, yippee, things are nice and awesome, right? So we're going to move this index I forward, right? And this is why we're never going to flip stuff from behind index I, because we've already set them to 1. We want to keep them that way, right? And so this allows us to do a nice linear scan from left to right. Now, when we get to this one, we see it's a 0. Shucks, we need this to be a 1, so let's do an operation, right? We're going to flip this from 0 to 1, flip this from 0 to 1, flip this from 1 to 0, right? Increment res by 1 because we just did another operation. And yippee, this guy's now also 1, right? So now let's flip our index I, increment our index I. Again, we're not going to touch anything from behind index I because these are all set to 1s. And then we're going to see, okay, we're at a 1. Great, we want an array of 1s. We're not going to do anything. So let's just move index I. We don't increment res, no flip operation, right? Now we're at a 0, so it's like, shucks, okay, I got to do an operation. Every single time I'm going to check, is it the case that I is greater or equal to length of nums minus 2, right? Think about it. This is index at length of nums minus 1. This is index at length of nums minus 2, right? So if I'm ever at a position where I need to flip something like this, well, I don't have enough elements to flip because I must do 3 consecutive elements and I'll never go backwards, right? Imagine this was a 1 over here that we just skipped. In a case like this, this is when we return -1, right? When we're at the very end, we're left with a 0, but not 3 elements to flip. Since we can't flip things before us because they're 1s, we must know, okay, we're at an impossible solution, right? Otherwise, in a case like this, here's like, we're index, we're 3 away from the end. So there's there's at least 3 numbers for us to flip. So we're chilling, right? Here's like it's a 0, so we must do an operation. So we'll flip this from 0 to 1, flip this from 0 to 1, and flip this from 0 to 1, right? Increment this by 1, and it's like, okay, now this is a 1. Let's move forward, right? Okay. Oh, this is also a 1. Let's move forward. We don't want to change anything. Oh, this is also a 1. Let's move forward. We don't want to change anything, and we reach the end of the array, right? So here we stop and we return our beautiful result res of 3, which is exactly what we wanted to do for example 1, right? And that's exactly how this algorithm works. And I can show you in writing. Essentially, I have res is equal to 0. We're going to iterate our way through nums for the index I and the bit. So it's like we only care. So first of all, if the bit is equal to 1, as we said, we just continue. It's already set to the good value we want, so we're just going to do nothing. So bit is equal to 1, continue. Otherwise, the bit must be 0. And we're first going to check, okay, are there at least 3 elements for us to flip, right? Because if we're at length of nums minus 2 or minus 1 for the index I, then we're in trouble, right? Because there's not at least 3 elements to flip. Everything before us is a 1. So we cannot make the array all 1s, right? So that's the case where we return -1, right? Otherwise, if this is not the case, then there's at least 3 elements for us to flip. So that's exactly what we'll do, right? I could say like, nums of I plus 1, it gets flipped and so on. But like, the point is I don't actually care what's in nums. I just care about like, the preceding succeeding indices. But if you're really paranoid, you could really just do this. But the point is that we're going to go to the next index and I'm never going to look backwards, so I might as well just skip doing the part where I actually augment the one for index I, right? So we want to flip the bits for index I plus 1 and I plus 2. Again, the index I1 is just kind of unnecessary because once we're done with this index I, and we'll move on to index I plus 1. But definitely the 2 succeeding neighbors are important, right? So the index I plus 1, we're gonna set it to we're gonna flip its value, right? So XORing by 1 flips it, right? Because if the bit is 0 and you XOR it with 1, this becomes 1, right? If your bit is 1 and you XOR it with 1, this becomes 0, right? Because it's exclusive OR. Here it's like, okay, it's exclusively a 0 and a 1, so that becomes 1, right? Here they're the same, so it becomes 0, right? So XORing a bit with 1 will actually flip its value, right? So that's why I'm XORing by 1. But you could do something. You could take this value, right, and you could say like this is equal to 1 minus this, right? Because 1 minus 0 brings you 1, and 1 minus 1 brings you 0, right? So it's like if this is 0, it gets turned into a 1, and if this is a 1, this gets turned into a 0, right? Or you can do something even simpler, right? Like we'll do 1 if this guy is equal to 0, otherwise 0, right? So it's like make it a 1 if it's 0, otherwise it was a 1, so make it a 0, right? Whichever way you do it doesn't really matter. I just realized if I XOR a bit with 1, it'll just flip the value, so we're just going to XOR it by 1. Also do it for not only index I plus 1 but index I plus 2 as well. And then it's like, okay, since we just performed an operation, let's augment res by 1 to indicate that, hey, we just did one more operation, right? And then we're just going to keep doing. If we never hit this case, then great, we're going to return res once we're done. Otherwise, we'll return -1 if this case ever happens. And bada bing, bada boom, we have a nice and efficient working solution, which I can show you right now by submitting. we have 121 ms beats 52.19%, which is a nice and awesome sauce solution. And yeah, so hopefully that solution makes sense. But otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So till then, ciao, ciao, my friend. Bye-bye.